Okay,
Sure.
let's. Okay, to keep going, please. Yeah. Hi, Ram.
Yeah. As per the BVM, that is Bitcoin Virtual Machine, I'm Ram, representing the Rust BVM for BSV community.
Okay.
So far we are almost done with the design phase. Like we have done the system architecture, and then the screen design was done, but we have some doubts regarding the API design. So
Okay.
coming to the project like this, coming to the project like the Bitcoin virtual machine, can you please guide us on what kind of APIs should we design on, or what kind of APIs should we focus on?
Just to
Okay,
interrupt, I'm sorry to interrupt. Would it be better, Zave, if you just listen what they have done so far, like things they present. If you want to have a look at it, you can ask them because they have been doing that.
Yeah, sure. If at all you want any kind of, if you want to see any kind of our work, you can please ask us. So far, we have done with the white paper, firstly, and then we have completed the system design architecture, and then the database design, and the screen design. Now we are left with the API design, which we need some guidance from you.
Okay, so can we do this? So basically, for the, this call is for everybody, for all the people, who watch almost weekly about our progress. So it will be great. We have a lot of people already in the summer code, but we also have a lot of people who's not in this code. So can you just take us back? Because this will be watched by people outside. So do you want to, go back and just give a high level introduction about what this project does and what do you want to achieve and what have been done so far? Is it okay?
Okay, sure.
Thank
So
you.
we are Team BVM. BVM, it stands for Bitcoin Virtual Machine. Specifically, we have divided this project into 3 phases. That is, with respect to the coding phase. First, it is building the Rust Bitcoin virtual machine for the Bitcoin SV community. That's phase 1. Phase 2 comes to enhancing the interoperability and the versatility of the Rust BVM, make different kinds of ecosystems like cross-chain, Ethereum, Solana, and etc. And third thing, we are, as a project, if the project gets successfully built, we'll be focusing on developer tooling and documentation. So this was the partitions I have made. So building, when it comes to the phase 1, which is building the Rust BVM for the Bitcoin community, so far as of now, we have completed 2 phases. First one, it is the research phase, in which we have created the white paper, in which it contains the detailed instructions, detailed research of what we have done in order to build the Rust BVM. So it contains all the instructions or the research that we have done so far. So that's the white paper. Secondly, design now. So what I instructed was to build 4 different kind of. Uh, we are instructed to design 4 kind of things. Firstly, it is the system architecture, meaning we have to design the entire system architecture of the BVM machine. Like what does it contain? What's the exact output, etc. What's the business logic within each and everything we have to design in this particular system design architecture. And then secondly, the database design, database schema design, where we have to create a detailed peculiar database schema design, so that we can implement it in the coding session. That is the coding phase of the TSOC, time chain summer of code. And thirdly, thirdly, it is the UI design. Like once the BVM gets built, it should be adaptable for the user community or the developer community. So it was very much similar to the Wasmer. You can see that in Wasmer.io, where it works similar to the Wasmer.io, and at the same time, its UI will also be similar to the Wasmer.io. So and then comes the API design. We have to develop the APIs in such a way gets divided into two, like as we are developing the web application, we will be using some of the external APIs, and at the same time, as we are building this Bitcoin virtual machine, we have to design some APIs so that we can use that particular APIs within our project, and also the developer specific APIs. Like the developers can use some of the APIs that they can use this particular project for their use. So if I can explain some of the core logic of this Bitcoin virtual machine, what we are supposed to do. Can I share my screen so that I can elaborate?
Yeah, sure. That'd be great. Yeah, go ahead.
Give me a second. I'm not very much used to Zoom, so can you instruct me where can? Okay,
yeah. Basically, yeah. You see that? That's a share screen. Yeah, just click that. Yeah, you should have the access.
Yeah. So can you say it, Charles?
Yes, I can see it.
Yeah, this was the Notion page that we as a team have built so that we can have a better understanding of the Rust BVM.
Can you enlarge a little bit, just so you know the recording will be easier to read? Okay, that's good. Okay, very good.
Yeah.
Yes.
So these were the high-level project objectives that we have to establish within the coding period. So there are 5 main project objectives. Firstly, we have to develop or establish a standard. So we have named it as .basm files, which is Bitcoin machine assembly files. So coming to it, we generally know the basic thing of how compilers and interpreters work, right? So compilers take in the program, and then it will spit out some kind of compile script, making it suitable for the interpreter to run it. So interpreter takes in that compile script and just runs it, and just it gives us the output. So in the same way, we are as we are in the BVM project. What we do is that we have to create a Bitcoin specific compiler in which it can deliver the .basm files. So we have to construct all the standards regarding the .basm file, so that that particular compiler just spits out this .basm file. So as per that, so this was a very this was the diagram which represents the key architecture of entire thing. So we have we have some kind of script. It could be Bitcoin script because as it runs on the stack based thing, or it could be some high level language script which we have to research a bit more on. So that will be
it's called ASCIIP. Okay. So,
sorry.
It's just ASCIIP. That's what we are doing here. ASCIIP. It's called ASCIIP.
Yeah. Okay.
ASCIIP. Yeah. It's just ASCIIP. Yeah. Go to ASCIIP.io.
Yeah.
You'll find it. Yeah, so that part is done. Yeah, don't worry about it. So you already have the high level
Okay.
language and also all the tools.
Okay.
Okay,
Script will. Yeah, I have a doubt. Sorry, like that will Script allow us to generate this kind of .bsm file that we can establish?
Yeah, if it's just assembly, you look at the script, right? You can be in two formats, usually hex, which is like a binary, and also human more readable is a ASM, so assembly format. I don't know if that's what you refer to here. So it's like
Oh,
op, let's say op add, op 5. Is that something you're trying to do in this format or is different? So that's
uh,
something, for example, you go to Watson chain, right? You look at block Explorer, and they will show you the the script part. Is that something similar to that format, or is it totally different? Do
I
you know
think
what I'm
it's
talking about? Watson chain.
sorry.
Do you know what I'm talking? Let me send you a example. The Bitcoin. Have you used the Watson chain yet?
Wasm chain.
Watson chain. Watson
No,
chain.
no,
Let's see.
I haven't used it.
Okay. Yeah, I think that will make your life much easier. Let me. Can I just quickly show you something?
Yeah,
Just
I'll
it
be
should be
done.
quick, like 1 minute. Let's let me show you one thing.
Yeah, sure.
So let's see. Okay, can you see my screen?
Yeah, sure.
So this is a BSV block explorer called Watson chain. So this is one transaction,
Okay.
right? I'm looking at the transaction ID. So it has some so-called script, right? The Bitcoin script here. This is the format it's using to display, which is also called the assembly format. Is this something the format you are trying to use, or you are using something different?
I think it is very much similar to this. We have
Okay,
to
that'd be great.
it's yeah a bit more on it.
Yeah, yeah. And for us, we already have, that's what we do, script. So script pretty much is what can compile the high-level language. Basically, it's a TypeScript DSL that can compile to script like this. You see, this is a script ASM format. So I would recommend you to be as close to this as possible because this is what already the ecosystem is has been using. So number one. Number two,
Okay.
take a look at us as script. We already have yeah, let's not try to build the compiler from ground up because it's heavy. It's a huge project, and we already done it. So this is like a pay to public hash. So yeah, we also have a lot of other contracts. So yeah, familiar yourself with our tool, script.
Okay, sure.
That'll be very good. Good. Okay. Yeah, I will let you keep going. Okay.
Yeah. So a script will let us to do the work similar to the compiler so that it can generate all the things that we require.
Yes,
So
yes.
yeah.
It outputs, yes, the Bitcoin script.
Okay.
You can reshare your screen again if you want.
Yeah, I'm doing it.
Okay, all right.
Yeah, as per the guidance, until here we can use the script.
Script
After
tools,
that,
yes.
so when we get with the compile script, we'll be inputting it to the BVM stack machine, and that will be generating the application that some particular user wants to build. It could be a distributed application uh, where they want to run their smart contract on the blockchain itself. So this was the entire flow that we are aiming for. So these were the these were the event partition tasks. We are
Okay,
very much done with
yeah,
this because as you have. So
yeah. Check that. Yeah, don't just reuse script unless you have a reason not to.
yeah.
Okay.
And then the second thing comes with the second project objective is that the environment API. Like we have to develop a environment API. Let me share you this thing. This diagram sums up everything. We have to create this environment API in which it creates some kind of abstraction layer or the middleware in such a way that whatever the smart contract that a user or a developer puts in, it can be run in any environment. It could be browser environment or it could be a standalone environment. I'm speaking about the dApps or the smart contracts that the user or the developer wants to get built. So we have to build this thing, environment API and the middleware. So these were some of the environments we were aiming for: browser environment and the standalone environment. We have to research a bit more on it. We will be doing that in the coding phase too.
Okay.
And then the third thing, we have to build a library of pre-built subroutine files, because as we all know that Bitcoin, the stack machine, the entire stack machine operates on the subroutine files, because it has some pre-built subroutine files, and whatever the things whatever the task that has to be done, it will be using some kind of subroutines. So this represents that particular thing. So this is the thing which we are even more researching on as we are going on with the design phase. We are not very much researched on it. So
I will give you some ideas. Yeah, I will give you some
sure.
ideas. So so basically, you want to have the interpreter, right, or the virtual machine interpreter, right, to interpret the what you call the BASM file here, right? And then you want to be at pretty much like a cross-platform or environment, whatever you call it. So we already have different languages interpreter. So basically, when we talk about the Bitcoin node software, right, that's one big part called the interpreter. So we have the original one, which is in C++. And then because we also write, we also have a Java version, we also have, so you have to check this one because you are trying to use Rust, right? So check if this is complete. So this probably will save you some time. Maybe you can reuse. I don't know how complete is this, but we have something maybe similar. I don't know if that's already complete. Check this. Maybe you can. I don't know how complete is this. Is interpret. It has something. Yeah. Check this. Maybe it's. I'm not sure if it's a. Say again.
Are you speaking about the Rust as we we have this thing?
Oh yeah, that's a different thing.
Okay.
I think that's only for. I'm not sure. Check. That's a different thing. So this one is specifically for Watson, and it has an interpreter. For that BSV, I think that library may not have an interpreter. That's my understanding. But you can check. Okay. Oh, it has a script too. So check how complete it is, because it may not be up to date. Check it. Yeah, I see it here too. Yeah, check another one. Yeah, this one is the one I've been playing with. So I also have JavaScript, Python, and Go, and C++ interpreter versions. So I think you probably don't have to start from scratch. That's number one thing. Okay.
And Shahi, if you have any kind of related to what we are speaking in the session, you can please put it on the chat so that we can use it for later.
Okay. Yeah. Also, I put it in the show notes also. Okay. I will send it in the chat. I will send it right now. Okay.
Okay.
I think check out this.
Very helpful for.
Maybe useful. Okay. So so you pretty much that's mine. Okay, let me. Okay, keep going. You have you want to keep going?
But Okay, I'll be explaining within short.
Mm.
That's basically about this building the pre-built subroutine files, and then the Oracle functionality, so that uh, the the entire ecosystem can fetch the data from the external sources, from the real-time data sources, without reducing any kind of security or things. So we have to establish things for that too. Uh, and yeah, we are pretty much with that. And coming to the questions, Shahi, as I have
Yeah.
said, the API design, uh, what kind of APIs we can, how we can build the APIs that are very much specific to the Rust BVM. So that would be our question with respect to the design phase.
Okay, number one thing I could think of, right? So basically, you want to have a service running that, hey, people, can you give me, this BASM file? Of course, you may put in a JSON, in a request, and then what you do is the service just simply run it, right? That's the number one thing I can think of. Does this make sense?
Okay.
Also, because when I don't know, in the future, right? The miners they don't want to do this themselves because it can be very heavy, right? So you are specialized. You guys know about the hashing, how to fix this, proof of work.
Yes. Yes.
So
The
proof of
minus.
work, right? Originally, when you run on your laptop, right? Maybe 13 years ago, you run everything on your laptop, including peer-to-peer script and script interpreter and also hashing. And then hashing become more and more competitive, right? So the miners then they outsource it to other guys. To this, they have special hardware to do it, right? So think about the script, this BVM, right? So as this gets more and more complex and transactions get more and more, you may have specialized guys, right? Their job is only to run the script, which is what you can do here, right? So basically, the miner say, hey, I don't want to run the BVM myself. I want to outsource it. So for me,
Okay.
I just give you the
Okay.
script. I just give you a script, and you just tell me whether it's good or not as a service, like a BVM as a service. So that's, I think, the number one API I
Okay.
can think of. Does this make sense?
Yeah. Yeah. Sure. Can I sum it up what you have said so that we can have clear runs on it?
Yeah, sure. Yeah.
So I'm just summing up
And
what you have said. Like, as for any blockchain, there will be miners so that they can earn their value that they need. So you are saying that create an API in such a way that miners can use that particular API in order to use the BVM machine. So
yes.
does it make sense?
Yeah, basically the miners, right? So they outsource the interpreting, the script engine to third parties. So you run that service, and they will just send you a request, and the response will be, "Hey, is this script correct or not?"
Okay. Okay.
That's the number
Sure.
one API.
That.
I'm even
Okay.
thinking of just brainstorming. Okay, so take this idea. So it's a brainstorming, right? So let
Yeah.
me show you something. Let me show you something. It would be maybe even good to have something, as an app. You can at the same time. That's as like a demonstration. Okay. So let me share my screen again. So previously we have this website. So have you guys heard about Remix for
Yeah.
Ethereum?
For
Okay, so
Ethereum and Solidity.
yeah, if you know about it, that should be similar here, right? So let's say we have this is, of course, this is old SQL file, but you can compile it, for example. Okay, and then you can do deploy, pretty much like a deploy, and then you can run it. Okay, so this is a script that you generate. This is, so the BVM here. Here's the thing. the BVM is running in the browser. You see here? So we have a VM, stack based, right? You probably know this, they have all the opcode. And here, the cool thing is you can also debug it. You can also, step through it. So I think it would be worth to have a first try. Basically here, this is the old script file. So now we have a TypeScript DSL, something similar to here. So it would be great demonstration if you guys have something like this, just remix, but for script and instead of for EVM, you can have the BVM and you can show the whole thing, right? So here, right, you can even finish, hey, is this good or not? So maybe you can do, maybe it fails, right? So let's say put 1 here, it should fail, you see? Then it will fail. So I just brainstorming. I'm thinking of have something similar here. People can easily get a contract deployed and run it in the browser. So that give a very good sense of what the BVM is, right? It's like remix, but instead of for EVM, it's for BVM. Make sense? So it's like a remix, but for BVM. Yeah, just something you guys can think of as a good demonstration for BVM, because if you only talk about service APIs, you also probably want to have some demo app on top of it, showing people how to integrate with the apps.
Okay. The third thing comes the apps. Okay. Got it.
Yeah, that demo app like remix, like I showed you the studio. Yeah, something to think about, because this is the browser that using JavaScript, but you can also run it using Watson, right? Once you have Watson, you can also run it in browser. BVM in the browser side, right? It's a good demo, I think.
I think this is
Okay.
very much related to the environment API that we have said earlier, because it will be creating a middleware within the system, and that will make the BVM to operate in different environments, like the browser environment or the standalone environment.
Mm-hmm.
Okay, we'll research a bit on it. And is there any other advice related to this, Sean?
Okay, so one idea again is I'm just brainstorming. We may not. I'm not saying we have to do that, but you think about even bigger, right? You guys heard about ordinals? Have you heard about ordinals on BTC and BSV and even Dogecoin? Ordinals, have you guys heard about
Yeah,
it?
no,
Okay,
we have Doge.
ordinals. Oh no, ordinals. The MT on BTC. Have you heard about ordinals?
No,
MT like
Sean, no.
MT. Oh, okay. Yeah, it's very popular these days. It's like ERC20, but on BTC. So there, the idea is, you can put data on BTC chain. So if we have this VM, the funny thing we can do is even where we can say we have, you can think of a layer 2 smart contract for BTC as well. So there is only for data, right? So we can put code onto BTC. Because BTC also have almost the same. It also runs a BVM, but it's a very limited version. Do you know the history of this, or I can explain a little bit more? So originally we have the BTC, right? The Bitcoin, and then it's split into BTC and BCH, and then BCH split. There's another split, BSV, BSV. Make sense so far?
Yeah, we are aware of
So yeah, they are similar. Opcode almost the same, but with slight difference. But the problem is for BTC, they disable most of the opcode. I think I send the article here. So let me share my screen again. So you can think about compatible. Can you see my screen? Browser? Can you see?
Yeah, it's visible.
Okay, so let me show the BTC stuff. Okay, so they also have the same opcode, almost the same, I would say, more or less the same. Here, but here's the problem. A lot of opcodes, you see the one highlighted in red, they're disabled. Okay, but all those they can be run native on Bitcoin SV today. But the problem for them is they disable it. So they're like you can think about a limited version of BVM. Okay, so they can run a very limited subset of a smart contract because all the useful ones are disabled. For example, you cannot even do multiplication. You could, let's say here, right? If you know BVM, you know this one, right? Basically, multiply the top two stack elements and push the result back to the stack. Okay, this is mount. So yeah, they disable a lot of opcodes. So this is like it's a crippled version of BVM. But here the thing is, so all the BVM can run fully on BSV, but only very limited on BTC. But here's the thing, right? We can do this on layer 2. Okay, yeah, this is another big, yeah, it could be a big undertaking, basically what I'm saying. It's just something you can think of. It could be huge. Basically, you are developing smart contract, but for BTC. But you don't do it at layer 1 because the opcodes are disabled. So you do it on layer 2. But the good thing is, all the BTC, BCH, Dogecoin, Litecoin, they almost use the same BVM, just a different. Some opcodes disabled, some are not. But again, this is a brainstorming. I just this is something I always have in mind. Okay.
Yeah, we have got it.
Okay. So yeah, I put a lot of things here. Basically, what I recommend would be get familiar with script tool set first, and that's what you're going to go from there. Because most likely the smart contract is not going to be written in script directly, because you guys all know, right? It's like it is assembly, and nobody wants to write a complex smart contract in assembly. That would be too much. Okay.
Okay.
Okay. Any other question? Or we can go to hardware wallet next. But I'm always there. Just ping me in the Discord. I'm always there. So, and any question, we will always talk. And then this is also weekly, so we can always come back and so I will keep track of your progress. Okay. But yeah, good job so far.
Okay, sure. Yeah, and Shahi, we'll be posting you the system design architecture that we have built so far. So kindly review
Okay.
it later on so that we can save time for the other team.
Yeah, sure.
Okay.
It's
Thank
going
you,
to be in
Shahi.
Discord or
Yeah, on
where is it?
Discord.
Okay. Okay,
Yeah.
I will do it. Okay. All right.
Yeah. Thank you, Shahi. Your advices are very much valuable for us. Thank you so much for the guidance.
Okay, no problem. My pleasure. Okay, is the hardware wallet team here or we're waiting on
Yes,
Rebecca?
all of them are.
Okay.
Yeah, all of them are here. Tommy,
Okay.
Sobit, the stage is all yours. You can introduce yourselves and introduce the project and what all you have been up to all this while.
Sorry for the interruption, Rebecca. Can we guys leave the BVM project?
You can leave. If you want to check out what the other team is up to, you can have a look at that also. No worries.
Okay, sure. Thank you.
Thank you so much, Ram. Yeah, you
Who's
can We can.
Who's representing hardware wallet?
Wait, what? Okay, I may have not added you on that channel. I give you the role right
Okay. So can
now. Yeah, that may be the.
who's presenting on behalf of hardware wallet team? Are they here? If
They
they're here,
are
we could
here.
get started. Okay. Who wants to talk?
Shobit, you want to take the lead?
Can somebody?
Mehul, are you there? Hello. Shobit, you are not audible.
Okay, if not Shobit, then Mehul or Swami.
Yeah, Mehul
Can
is
get some?
Also, Zavia, I've added you on mobile hardware wallet Discord channel.
Okay, I'm not. Do I have to refresh or something? Okay, let me see.
Hello.
Yeah, hi
Yeah,
Mehul.
we can do that later.
Hello.
Yeah. Can somebody, from
Yeah,
that team, start the introduction?
yeah. So Mehul, and till now we have done the white paper thing, and we had some doubts for which we wanted to ask you, like how can we move further. So first of all, I'll present the white paper. Just a second.
Okay.
Is
Okay.
my screen visible?
No, it's
Yeah,
still
I can
not
see it.
visible.
Yeah, I can see it. If you want to share screen, please go ahead.
Great. I'm having some issues. Yeah, is my screen visible
Yeah.
now?
Yes. Go ahead.
Yeah. First of all, I'll take this one.
Mm-hmm.
Yeah, so basically according to till now what we have researched is we are going to replace the physical keys with our mobile phones, and
Yeah.
like mobile phones have a say like secure enclave inside themselves, like the microprocessors inside the mobile phones generate a unique key which we can use for our private keys. And like it is a similar concept to banana wallet which they have right now. So I'll present it to you right now. So the problem which we are addressing is the need for a suitable system that securely store keys, allows easy access to the internet for transaction signing, enables mobility without raising suspicions. While hardware wallets provide high security, they are inconvenient for frequent transaction and can be expensive. So we require a solution that combines security, affordability, accessibility along with mobility. So Bitcoin as a decentralized digital currency demands robust security measures to protect user funds. Hardware wallets have emerged as a popular solution, but they become with their own drawbacks. Like they are like the physical wallets which we buy, they are very costly. and while using a mobile phone for that will be a very cheaper option and mm, like a convenient option for everyone. To address these issues, there is a growing demand for integrating Bitcoin wallet functionalities directly into the smartphones. Designing a hardware wallet that utilizes a secure enclave for Bitcoin private key storage is a complete task for us. So we need to consider these factors like the choice of secure enclave platform. Like Android have different and iOS have different. The key generation and storage, key usage and signing, and user authentication. These nuances require careful consideration to ensure that the effectiveness of the solution. And we have identified several potential solutions to address the problem at hand. One approach is to use the Apple Secure Enclave technology on iOS devices, which provide a dedicated hardware-based secure execution environment. So, and for Android, there is TEE, Trusted Execution Environment, along with ARM Trust Zone. So we are still confused to use which one for and implementing mobile hardware can have significant impacts on the block industry. First is mobility and access, and allowing users to securely store their key on their smartphone and make transactions from anywhere, anytime. Second, it reduces expenses for users as they can utilize their existing smartphone instead of purchasing additional hardware. It also simulates innovation among smartphone OEMs, pushing them to provide secure enclave features and driving competition in the mobile hardware key store SoC market. Um, technique Before implementing any solution, a feasibility study is crucial. From a technical standpoint, the availability of secure enclaves in modern smartphones make it feasible to leverage them for like Bitcoin wallet functionalities. Integration and development efforts and market demand also needs to be thoroughly evaluated to ensure a successful implementation. At last, we have explored the problem statement, background, along with some problem nuances, impacts, and feasibility study of the mobile hardware wallet, utilizing the secure enclave or trusted key for Android. Depending on the target audience, we can you like for iOS, we can use secure enclaves. We can like use the viable solutions, and it is important to evaluate each option carefully and choose to one that aligns best with our objective. So like for the Apple one, which we got the article is here, uh,
Okay.
and for Android.
Okay.
So
So
basically,
can I ask?
Apple itself have, yeah, sure.
So basically, okay. So you probably know this. I just want to make sure the high level is clear. So, just a few months back, we published this article. Also you put in a reference, the last one, I think. So basically, you can turn every mobile phone into a secure hardware wallet by using the, so-called secure enclaves, right? But the problem is they're using a different curve
Yeah,
than the native Bitcoin is using. So to use
yeah,
that, the
six to
curve, we
56.
have to use, yes. So we have to use a smart contract to program the new curve so we can support it. Make sense, right? So far. But here's the thing,
Yeah,
that's only an idea. I think should work, but the problem is nobody has implemented it so far. So it would be great if you can, this project for me is just an
I
implementation of
think
that idea.
there is an SDK called Banana Wallet. They have implemented it.
Which one?
Banana.
Can you put, is it
I
in the
can
white
send
paper
you.
or what's it called? What's it called?
No, it is in the like they have published it. It is for early access right now. I can send the link right now.
And just send the
Okay.
link in the chat.
Yeah, yeah.
Anyone.
Send the link.
What is this? Banana. This use enclaves?
Yeah,
Or no?
yeah, yeah. In the features, you can check Touch ID authentication.
Really? Okay. I have to check this. Is this using the same
Yeah,
idea, or this is for
yeah. They
Ethereum or
are
what?
using the same idea. Yeah, this is for
Let me just.
Ethereum and Polygon also.
Is it
I've used
ready?
this
Is
on
it
Polygon.
is it
Yeah, I
working?
have used this in one of my hackathon.
Oh, okay. Uh, does it implement the new curve, or because Ethereum is also using R1 by default, right? It doesn't support K1. Is it right? Do you see what I mean?
Uh, I don't have the idea about that because they haven't mentioned about this thing.
Yeah, my guess. Okay, you can check later. You can help me check. They are not using the key directly. Basically, they can. So there are two ways to use the secure enclave. First, you only use that for signature. Okay, you directly using the key to sign the transaction. Okay, that's what we are trying to do here. So for the other people so far, my understanding is they don't use the key to sign the transaction. They use the key to encrypt another key. So secure enclaves basically have two interfaces. One is digital signature. The second one is encryption. So I think that's my but you can check later. I think that the way they are using it is to use the secure enclave key to encrypt another Ethereum key, which is not what we are trying to do, and it's not as secure. You can check, but that's my guess. That's what based on my understanding, because I don't think that you can do the new curve check check the signature on the old curve. No, using the new curve with Ethereum. It's just too expensive. The transaction size will be like, I don't know, hundreds kilobytes or something. I think that's just my high level guess without getting detail. Can you check? Basically, that's not what we're trying to do here. It's not a secure.
I'll
You still, the private key for the transaction is still exposed. It's just encrypted with a secure enclave key. That's my guess, but you can check here, right? That
yeah,
you're
I'll
supposed to
check
use
with that.
this. Yeah. Do you see the difference? What two approaches I just mentioned?
Yeah, yeah, yeah.
Okay. Check that. And even if they have done it, but it's not for Bitcoin, right? Let's do it for Bitcoin. So pretty much do this, but by using the secure enclave to sign the Bitcoin transaction. So it's as secure as a hardware wallet, as you said, right? Then the benefit is you are even you are using your phone, you don't have to buy another hardware wallet, which is a hassle. And also it's more convenient, right? You can use all the fingerprint and face to log in and sign a Bitcoin transaction. It's convenient and also secure. It has a both. You enjoy the benefit of both, right? The so-called cold wallet and hot wallet. Right? Hot wallet is convenient, but it's always online, so it's not secure. But hardware wallet is secure, but it's not convenient to use, right? You have to connect, air gap, yeah, all kinds of things. So if you can do this, it'll be most convenient and also most secure wallet. So one stone, two birds. You get the idea, right? I think since you already done all the research here. Okay.
Yeah,
So on the high level, I just want to make sure we're on the same page. So it's also idea conceptually is very simple. So you write a smart contract. So you build a, let's say, iOS wallet. So whenever you lock up some coins, you lock up coins in that smart wallet. smart contract, okay, which is mostly does a verification using the K1 curve, right? So if it checks out, then you can move the coins. That's it.
Okay.
Do you see? Yeah. So what's the status now? Is it
We are in the
just
design phase
about to?
right now.
Okay, design phase. Okay. You know, I would suggest to, you know, instead of doing the heavy stuff first, build a like a prototype, very primitive prototype. So basically, have some get the contract going, deploy the contract, and you know, make sure it works without using, let's say, mobile phone. Let's say using some kind of Node.js or JavaScript library. So just run this example, make sure that's good, and then look
Like
at
you are
the secure
asking
enclaves.
to deploy a normal smart contract and try with that first without using the secure enclave.
Yes, because the the principle is the same, right? The algorithm is the same. So first, make sure this works. Let's say using JavaScript or Node.js or whatever your favorite thing is. Deploy it, and then make sure this
We
one
are
checks
making a
out on
mobile
the
app.
testnet. Yeah, that's what I'm saying. You can even before that, you can do like a simple proof of concept using, you know, Node.js or JavaScript. Make sure this checks out, and then you can do integrate. You know, so first, right? You can generate all of this. You can do without a mobile phone. Agree? So you are simulating the secure enclave, right? Signing. You can do it in code, yeah, using our SDK. Once you make sure that works, then you can migrate to mobile phone. That's just my suggestion. But you can also skip it if you're already familiar with all the framework here. You can just go directly to mobile. Okay.
Like I'm a mobile developer, so I haven't
Oh,
worked with Node.js and
you
all.
don't do like a Node.js and stuff. Oh, that's even
Yeah,
better. I mean, okay. So okay. So do you have any questions or blockers, or you're just design and then finish. Once you finish that, you can just go implement it.
first we'll do the design phase, and if we have doubts during that phase, we can ask you.
Okay, sounds good. All right. All right. Any other questions? Yeah, banana.
Like we might need some help with the like during the implementation of the secure enclave because it's a new concept for us.
Yeah, yeah, sure. Anytime I'm here, so I'm not traveling anymore. So just ping me, and you know, we'll help you out. Okay, to make at least the contract part. I'm not the mobile phone developer expert, but I know something about the contract for sure. Okay.
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 Yeah, guys,
Sounds good.
guys always available on our Discord channel. So his username is same first name. So if you have any doubts,
Uh-huh.
any immediate queries, you can just ping him on the channel there itself. Be available. He responds very
Yeah.
quickly, by the way.
Okay. Okay. All right.
Yeah.
Okay.
So
Sounds
if
good.
nobody else, any other questions, I guess we can conclude this session for today.
Okay. Thank you, everyone. Yeah. Keep up the good work. Okay. I will look forward to see what you guys finish. Good. All right. Have a good one. Bye bye. Rebecca, Domingo.
Bye.
Bye bye.
Have a nice day.
Okay.
Bye.
Visit.
Bye.
Bye bye. You too. Bye bye. Have a good night.